Alrighty, moving on to some of our first definitions. So the first distinction I'm going to make is between a sample and a population, and I mentioned this a little bit briefly last week. Samples and populations are really important because they are the people that our research question applies to and the people that our data come from. So a population is a wider group, it's a broader group than a sample, and it's generally the people or the observations that we're interested in finding out something about. So it's the wider group, the broader group. In terms of psychology, it's usually people, but not always people, that we're interested in finding something about. And research questions are always about a population. If I'm interested in understanding the effect of psychological therapy on depression, my population is Australians with depression or everybody in the world who has depression. That's the wider group that I'm interested in, that the research question applies to. The sample, on the other hand, is the people or the observations from whom you actually collect the data. So if I'm interested in understanding the experience of people with depression, I might ask 50 people who have depression what their experience is, and those 50 people make up the sample. And the sample is the people from whom you actually collect the data. When you have information from people or from anything else, that's your sample. So data are collected from your sample. So let's say that my research question was wondering if attending study group sessions, so sessions where you get together with peers and study together, whether that improves your final marks on a particular unit. The population, the group that I'm interested in terms of my research question, could be all university students in Australia. It could be all students in general in Australia. It could be all students across the world. It's going to be dictated by the researcher themselves. The researcher sets the population of interest, and it's generally the wider group that you're interested in, that your research question applies to. My sample, on the other hand, could be just 500 students from Macquarie University, and I could ask them questions about studying, their study habits, and I could measure their final exam marks, and I could use that to see if there's an association between study group sessions and final exam marks. So the sample are the people from whom you actually collect the data. The population is the wider group of people to whom the research question applies to. For example, to give you a second example, let's say that our research question is whether physical punishment To give you a second example, let's say we were interested in whether physical punishment makes children more obedient, whether children whose parents are physically punishing them, physically reprimanding them, whether that makes the children more obedient. So our population might be all Australian children, say we're defining children as those up to 12 years of age, but our sample might be, say, 150 children who were selected from Sydney primary schools. So the sample are the people, in this case the children, that we're collecting the data from, whereas the population is the broader group that we're going to generalise our findings to. And as I said before, the researcher themselves, the person who's designing the study, who's conducting the study, who's analysing the data, they're the ones who will designate what the population of interest is. So depending on what your research question is, you'll have different populations that you're interested in. If I'm interested in how young people learn to drive, my population might just be those who are 16 years old on their Ls, say, in Australia. Depending on what your research question is, your population of interest will be different. And the population of interest is identified before you've actually designed the study and collected the data. So the first step is to work out who you're interested in general, and therefore to work out who the sample is who's representative of that population. And when you collect data, analyze data from a sample and make a conclusion, the conclusions from the data that you've collected from the sample are always made back to a population. So conclusions from a study, the take-home message from a study, is always applied back to a population. Conclusions are always about a wider population. And if your sample isn't representative of the population, then that can lead to you to have problems when you're trying to make these conclusions. So a sample needs to be selected so that they're representative of the population. They need to be selected specifically so that they are in no way a biased representation or a misleading representation of the population. If your sample are not representative of the population, that means that you can have flaws in your conclusions that you make. Alrighty. Along the same kinds of lines, we've got a distinction between what we call a parameter and a statistic. And these are numbers that we use to summarize data. Parameter is going to be a numeric summary which applies to the population. So it's a numeric summary of the population phenomenon. Whereas a statistic is a numeric summary but of the sample itself. So to give you an example, let's say that we knew that the average age of university students in Australia is 20 years old. So the mean age, the average age of university students in Australia is 20. I'm making that up, but I reckon it sounds about right. That's going to be our parameter. That's a numeric summary of our population, our wider population of interest. We could have a sample of 100 university students, 100 students who are randomly selected from universities across Australia, and the average age in that sample, let's say, is 22 years. And that's going to be a statistic. The statistic represents the sample, it's a summary of the sample, whereas the parameter represents the population. What we tend to be interested in as researchers is parameters. We tend to want to know things about the population. As I said before, the research question generally is about the population. So what we want to understand is parameters, is ways of summarizing a population. But generally speaking, the thing that we have information about, that we have actual data for, is the statistic. That's the representative of the sample itself. And our process of what I'm going to call inferential statistics, and I'll define that in a couple of slides' time, is going to be learning from our sample to make generalizations, to make an inference, to make a generalization back to a population. All right, data and variables. So a couple more definitions for you. Hopefully you're still with me. A unit of observation is the level of observation that you're interested in sampling. So for the majority of time, for your experience, and certainly in psychology and linguistics and education, the unit of observation is the person. I'm interested in information about a person. My population is a group of people. My sample is a group of people. So most of the time, the unit of observation is going to be a person, but it's not always. So maybe we're interested in looking at daycare centres, and so we're looking at how many staff are employed at a daycare centre. We're looking at the different kinds of educational programs that are run in the daycare centre. In that case, the unit of observation would be the daycare centre. It's not a person level. If I'm interested in organisations and how organisations work most effectively, how they train their employees and kind of upskill them, then the unit of observation is going to be the organisation, the company itself. So for most of the time, the kinds of research questions we deal with, the unit of observation is the person, but it's not always. There are exceptions to that. The next thing to talk about is data. So data describes a collection of information, a group of information that has been recorded from your particular sample. So data are pieces of information, usually responses to something, responses to questions, say, that are a summary of your sample. And the data are pieces of information that specifically apply to your research question and your hypotheses. And for our purposes and the kinds of statistics we're doing, data are usually set up as a spreadsheet. I've got an image of that in a second. There you go. So we usually set up a spreadsheet which contains all of the data from a particular project, say a particular research study. This spreadsheet will also contain multiple variables, usually. And variables are pieces of information, individual pieces of information, that you have collected about your sample, so you've collected data on, which varies among participants in your sample or among participants in your study. So I could have one variable, which is my participant's age. So each participant gives me a piece of information, which is their age, and that variable is age. It's something that varies, that changes across people in my sample. In this spreadsheet, I've also got a variable which is the person's name, the individual's name, and I've also got a variable which is the unit that they're studying at Macquarie. So here I have, in this spreadsheet, this Excel spreadsheet, I've got 3 variables and I've got 4 observations. The unit of observation here is at the person level because I've got information about individual people. So we've got 4 observations in this data set, in this collection of data, and I've got 3 different variables. And this will become a very familiar sight to you because this is how we're going to view the data sets, the kind of collections of data that we are going to be using for the statistical analyses for the rest of this course, and if you go on to do more psychology research methods and stats for the rest of your undergrad. Okay. Next, let's talk about types of data. So we have different sorts of data, and the different types of data just represent what kind of information they're actually storing. So the first thing to think about is it numeric information? Is it some kind of a number that you've represented, that you've measured, or is it some kind of descriptive information? So numeric information, which is also called quantitative data, is something that has an inherently numeric property to it. So it's something that is measured on a numeric scale, a number scale. So for example, age, how many years old are you? That's a numeric variable. If I think about how tall are you in centimeters or in millimeters, that's a numeric variable. How much do you weigh in kilograms? What's your SNG? What was your ATAR? Anything that has that numeric property to it is called a quantitative variable or quantitative data. We can also have qualitative data, which is more descriptive. So that isn't inherently numeric, but it's just something that describes or is a type of thing. So for example, if we wanted to represent what was everybody's favorite color, what suburb do you live in, what type of car do you drive, brand of car, what department across the university are you studying in, where do you work, anything like that, which is more of a descriptive piece of information, that's called a qualitative piece of data or a qualitative variable. So to think about whether it's a quantitative or a qualitative data or variable, think about if it has a numeric property. If there's something inherently numeric about it, then yes, it's quantitative. If not, then it's qualitative. We can also have discrete or continuous data, and discrete data is something that is in individual groups or categories of things, whereas continuous data is something that could be at any point on a particular scale. So for example, let's think about what year of school kids are in. So if you think about years of school, we have kindergarten, we have year 1, we have year 2, we have year 3, all the way up to year 12. That's a discrete variable because there are discrete categories along that scale. You can't have year 1.2 or year 1.35, it just doesn't make sense. Whereas on the other hand, if you think about temperature in Celsius, temperature is a piece of continuous data because you could have any particular point on the Celsius scale. You can have 13.25673 degrees, and that's a valid observation. That's a valid point on that scale. So discrete data are in discrete kind of categories, even if it's a numeric variable, whereas continuous data is something that can be at any particular point on a scale. All right, the next thing to talk about is measurement levels, and these are different kinds of variables, which I'm going to link back into that quantitative and qualitative distinction that was on the previous slide. So here we've got a distinction between 4 different kinds of variables. At the bottom of this diagram on the right-hand side, you can see that we've got nominal variables, then ordinal, interval, and ratio variables. So nominal variables are the lowest category. They're the least specific and the most general category. Nominal variables are unordered categorical variables. So if you think about anything that can be put into categories or types of things, and there's no order or hierarchy or leveling to the types, that's a nominal variable. If you think about color, if you think about gender, if you think about department across the university, if you think about suburb, if you think about what university you're studying at, all of those are examples of nominal variables. They're things that are distinct categories or types of things, but there's no order or hierarchy or leveling to them. A particular type of nominal variable that you can have is called a binary variable, and that's where you have a nominal variable with only 2 categories or 2 types. So say you are measuring whether somebody drives to uni or not. and the answers were yes or no. That's a binary variable, which is also called a dichotomous variable, which is also called an indicator variable. These are all three terms for the same thing. And that's just representing a categorical variable with two possible types, two possible categories. Yes or no, present or absence, one or two, anything like that. The next level up of variables is called an ordinal variable. Ordinal variables are still categorical in that they're still distinct types or categories or qualities of something, but there is an order to these levels or the types or the categories of this variable. So let's say we're thinking about level of education. You could have at maximum a high school education, you could have at maximum an undergraduate degree, you could have at maximum a postgraduate degree. This is still a categorical variable because we have categories or types of things, but it's an ordinal categorical variable because you can say that a postgraduate qualification is a higher level of qualification compared to undergraduate. An undergraduate qualification is a higher level of qualification than a high school diploma. The next step up is an interval variable. So an interval variable is a type of numeric variable, and it's on a numeric scale where there's a consistent difference between points on the scale, but there's no meaningful 0 point on an interval scale. So let's say we're talking about a standardized IQ intelligence measure. Somebody with an IQ of 100 points is 1 point higher than somebody with an IQ of 99 points, which is 1 point higher than someone with an IQ of 98 points. So there's a consistent difference between the points on this scale. But in the example of IQ, if you scored 0 on the IQ measure, it doesn't mean that you literally have 0 intelligence. 0 is just a somewhat arbitrary point on the scale. So that's an interval numeric variable. The highest kind of type of variable, measurement level for variables, is a ratio variable. And this has all the properties of an interval variable, plus it also has a meaningful 0 point. So for example, if you're on a ratio scale, let's say we're measuring weight in kilograms. If something weighs 0 kilograms, it has literally no weight. A 0 point on a ratio scale means it's an actual absence of the thing that you're trying to measure. If you are 0 years old, you have no age. If you have measured something that's 0 centimeters, it has no length. So a ratio scale has an absolute 0, plus it has all the properties of the interval scale as well. So as you can see, the distinction that we had from the previous slide, which was between a qualitative and a quantitative variable, we can apply that to these 4 different measurement levels. Nominal variables are qualitative variables because there is no numeric property to them, they're just descriptors of something. Interval variables are quantitative variables because there is that numeric property, is something on a numeric scale. And similarly for ratio variables. Ordinal variables are a little bit special. They can be either qualitative or quantitative. So you could have an ordinal variable which is, say, what position you finish in a race. You could finish first or second or third. It's technically an ordinal variable because it doesn't meet the requirements of an interval or a ratio variable. It's still categorical in that it's still a descriptor of the place that you are, but it still does have that numeric property, so it's technically a quantitative variable. On the other hand, if we're talking about level of education, that is an ordinal variable, which is a qualitative variable. There's no numeric property to it. It's a descriptor. It's something that's describing